Hello guys, welcome to my channel. Today we are discuss about general organic chemistry. Introduction. Organic chemical compound appear in materials like the clothing, fuels, polymer, dyes and medicine. F. Wheeler synthesized an organic compound urea from an inorganic compound ammonium cyanide. If we treat ammonium cyanide in presence of heat, then you can get urea. Structural representation of organic compound. Complete condensed and bond line structural formula. Organic compound structures are represented in several ways. The Lewis structure, dot structure, crash structure, condensed structure and bond line structure formulas are some of the specific types. Secondly, the Lewis structures, however, can be simplified by representing the two electron covalent bond by the dash line. Thus, ethane C2H6, ethene C2H4, ethyne C2H2. Such structural representation are called complete structural formula. Ethane can hold only a single bond. Ethene can hold double bond. Ethyne can hold triple bond. These structures can also be represented by the following ways: ethane, ethene, ethyne. Organic chemists use another way of representing the structure, in which only lines are used. In this bond line structure representation of organic compounds, carbon and hydrogen atoms are not shown, and the line representing carbon-carbon bond are drawn in a zigzag fashion. For example, 3-methyloctane can be represented in the various form as CH3, CH2, CH, and this methyl group is in contain the isoposition and 4 times of CH2 group and the terminal CH3 group are present. That is the 3-methyloctane, and here we represent that the 3-methyloctane in a zigzag manner, and the terminal 2 points represents the methyl groups. Then vigorous way of representing 2-bromobutane. Here is the chain structure of 2-bromobutane, and there is the B which can represent that the zigzag structures of 2-bromobutane. Next, in cyclic compound, the bond line formulas may be given as follows. At first, cyclopropane, there is a triangular shapes. Next, cyclopentane, there is a cyclopentane and each point contains one CH2 groups. And next, chlorocyclohexane, and one Cl group is replaced by a hydrogen, right? Next, three-dimensional representation of organic molecules. The three-dimensional representation, 3D structures of organic molecules can be represented on paper by using the certain conversions. For example, by using solid and dashed wedge formula, and the 3D image of a molecules from a two-dimensional pictures can be perceived. The solid wedge is used to indicate a bond projecting out of the plane of paper towards the observer, and the wedge or the dashed wedge is used to depict the bond projecting out of the plane of the paper away from the observer. Next, the bond lying in the plane of the paper are depicted by using a normal line, wedge and dash representation of CH4. And the solid wedge, that means bond towards the observer, and the dashed wedge, that means bond away from the observer. And the two line represent that the bond in the plane of paper. Next, classification of organic compound. Organic compound may be classified in the two types of compounds. One is the acyclic and or the open chain compound, and the cyclic or the closed chain or the ring compounds. Then the cyclic or closed chain or the ring compounds can be classified in between homocyclic or the carbocyclic compound, and another is heterocyclic compound. And the homocyclic or carbocyclic compound can be classified into two between these. One is alicyclic compound, another is aromatic compound, and the aromatic can be also classified in benzenoid compound and the non-benzenoid compound. Alicyclic or the open chain compounds. These compounds are also called as the aliphatic compound. That means consist of a straight or the branch chain compound. For example, ethane, isobutane, acetaldehyde, and acetic acid. These structures all contain a straight or branch chain compounds. Then alicyclic or the closed chain or the ring compounds. Alicyclic or the aliphatic cyclic, that means these compounds contain atom joined in the form of a ring, and this is called a homocyclic. Sometimes atom other than carbon can be represented in the ring. These are called the heterocyclic, and some example are cyclopropane, cyclohexane, cyclohexene, because here is one double bond is present, and the tetrahydrofuran. This is the example of heterocyclic because atoms other than carbon are present in these furan structures. Next, aromatic compound. Aromatic compound are special type of compound. These includes benzene and other related ring compounds. This is called benzenoid. Benzenoid aromatic compounds. One is benzene, another is aniline. Aniline, that means one benzene is a base and another is a substituent group, which NH2 group is substitute of a hydrogen. And the next is the naphthalene. Here is the two benzene ring are fused to each other. Next, the non-benzenoid compound. This compound does not contain any benzene ring as a base. So the example is the tropolene. Tropolene is a 7-member ring structure and contain one keto group. Okay. Next, heterocyclic aromatic compounds. Here is other atom is present with carbon atoms. And the example is furan, thiophene, and pyridine. Nomenclature of the organic compounds. In order to clearly identify compounds, a systematic method of naming has been developed and is known as IUPAC, that means International Union of Pure and Applied Chemistry system of nomenclature, and the names are correlated with the structure such that the reader or listener can deduce the structure from the name. The traditional name are considered trivials or common name. Common or the trivial name of some organic compounds. One is compound is methane, compound name methane. CH4 is compound and compound name is methane. Next, CH3, CH2, CH2, CH3. This is N-butane. Next, CH, and there is two CH2, CH3. One side and another side is one CH3 is linked up, and the common name is isobutane. And if you look like a structure of neopentane, then you get that the 3 CH3 group is attached with the 1 carbon atoms. Next, formaldehyde. There is a aldehyde functional group is present and with a 1 hydrogen atom. So the common name is formaldehyde, and the acetone, there is a ketone group present. Chloroform, there is C3Cl, but 3Cl or halo group are present in 1 carbon. Next, acetic acid, there is CH3COOH, 1 acid group is present. Acid group, it's a functional group, right? Then benzene, that means C6H6. Anisole, that is C6H5OCH3. Aniline, C6H5NH2. Acetophenone CH3 C6H5CO CH3. Ethyl methyl ether. There is contains a ether functional group. One is CH3O, another is C2H3. Next, the IUPAC system of the nomenclature. There is a hydrocarbons, and the compound contain carbon and hydrogen only are called the hydrocarbons. And the above structures look like a structure that CH3, CH3 and CH2, CHBr, CHOH and CH3. There is CH is a parent chain and OH is a functional group and Br is a functional group. Next, the hydrocarbon. Hydrocarbon can be classified into two types. There is saturated and unsaturated. Saturated, that means a hydrocarbon is termed saturated if it contains only the carbon-carbon single bonds. Unsaturated hydrocarbons are those which contain at least one carbon-carbon double or triple bonds. IUPAC nomenclature of the alkenes, straight chain hydrocarbons. The name of such compounds are based on their chain structures and with suffix "n" and carry a prefix indicating the number of carbon atom present in the chain except from CH4 to C2H10, where the prefix are derived from the trivial names. IUPAC name of some unbranched or saturated hydrocarbons. First, methane CH4, ethane C2H6, propane C3H8, butane C4H10, pentane C5H12, hexane C6H14, heptane C7H16, octane C8H18, nonane C9H20, decane C10H22, icosane that is C20H42, and the triaconitan that is C30H62. Branched chain hydrocarbons. In a branch chain hydrocarbons or compounds, small chain of the carbon atom are attached at one or more carbon atom of the parent chain. The small carbon chain or the branches are called the alkyl group. There is methyl branch, ethyl branch and so on. And at first A, there is CH3, CH, CH3. This is isoprociation and CH2, CH3. And next CH3, CH. This is ethyl group CH2, CH3. And then in the 2 position and next 4 position there is a methyl group is attached on the parent chain. In order to name such compound, the name of the alkyl group are prefixed to the name of the parent alkene. An alkene group is derived from a saturated hydrocarbon by removing a hydrogen atom from carbon. Thus, CH4 becomes CH3, it is called methyl group. And C2H6 becomes CH2CH3. It is called ethyl groups. Next, alkane and alkyl group. CH4, name of alkane is methane. Structure formula bond CH3 and the name of alkyl group is methyl. Next, C2H6 ethane, CH2CH3 and the ethyl. C3H8 propane, CH2CH2CH3 propyl. C4H10 butane, CH2CH2CH2CH3 butyl. C10H12 decane, CH2 the whole 8 and CH3 decyl. Nomenclature of branch chain alkane. First of all, the long carbon chain is the molecules is identified. Example, there is CH3, CH, CH3. Methyl group is present in carbon 2 position. There is a isoprociation. Then CH2, CH2, CH2 and CH3. There is ethyl group is present in carbon 6 position. There is also isoposition. And then CH2, CH2, CH3. Next, the numbering is done in such a way that the branch carbon atom get the lowest possibility numbers. There is next the 3 point is if different alkyl group are present, they are listed in the alphabetic order. So here is Here is in the above, look at the above structure that ethyl group is present at 6 position at carbon 6, and the methyl group is present at carbon 2, and due to alphabetic order we prefer the ethyl group at first, then we take the ethyl group. So the name for the compound shown above is 6-ethyl 2-methylnonane, not ethyl. Here is a mistake in the PDF, but the actual name is 6-ethyl 2-methylnonane. Note, the number are separated from the group by hyphen, and there is no break between the methyl and nonane. Okay. Next, the point is 4 is if two or more identical substituent group are present, then the number are separated by commas. The name of the identical substituent are not repeated, instead prefix such as di for 2, tri for 3, tetra for 4, penta for 5, hexa for 6, etc. are used. And the name is 2,4-dimethylpentane because CH3 or methyl group present in 2 and 4 position equally, then we can separate these two by a comma. And the another example is 2,4-trimethylpentane. Next, if the two substituents are formed in the equivalent position, the lower number is given to the one coming first in the alphabetical listening. The branch alkyl group can be named by following the above mentioned procedures. Carbon atom of the branch that attached to the root alkene is numbered 1 as the exemplified below. There is 1,3-dimethyl-butyl. While writing the trivial name of substituent in alphabetic order, the prefix iso, neo are considered to be the part of the fundamental name of alkyl group. The prefix sec and the tat are not considered to be part of the fundamental name. In multi-substituent compound, the following rules may be remembered. If there happen to be two chains of equal size, then that chain is to be selected which contains more number of the side chain. Okay. Next, after selection of the chain, numbering is to be done from the end closure of the substituent. For example, there is a big structure and the name is 5,2-ethyl-butyl 3,3-dimethyl decane, not 5,2,2-dimethyl-butyl 3-ethyl decane. Okay. Next, cyclic compound, a saturated monocyclic compound. Compound is named by prefixing cyclo to the corresponding straight chain alkene. If the side chain are represent, then the rule given above are applied. Name of same cyclic compound are given below. Cyclopentane 1-methyl 3-propyl cyclohexane. There is an alphabetic order of the numbering. And the next, the more branched carbon get lower number. Okay. And the name is 3-ethyl 1,1-dimethyl cyclohexane, not 1-ethyl 3,3-dimethyl cyclohexane. Okay. Then the next is nomenclature of the organic compounds having the fundamental groups. Functional groups as defined earlier in an atoms or a groups of atom bonded together in a unique manner, which is usually the site of the chemical reactivity in an organic molecules. For example, CH3OH, methyl, CH3CH2OH, ethyl, and the CH3 whole to CHOH, this is isopropyl, all having OH, that means alcohol functional group liberated by the hydrogen atoms, liberate hydrogen atoms on reactions with the sodium metals. Okay. First of all, the functional group present in the molecules is identified with determines the choice of the appropriate suffix. The longest chain of the carbon atom containing the functional group is numbered in such a way that the functional group is attached at the carbon atom processing the lowest possible number in the chain. In the case of the polyfunctional group, one of the functional group is chosen as the principal functional group and the compound is then named on that basis. The choice of the principal functional group is made on the basis of order of preference, and the order of the decreasing priority of some functional group is COOH acid, bond SO3H, bond COOR, COCl, CONH2, CN, HCHO, keto group CO, OH, alcohol group, and NH2 amine group, C double bond C alkene group, C triple bond C alkyne group. Nomenclature of the substituted benzene compound. For IUPAC nomenclature of the substituted benzene compound, the substituent is placed as prefix to the word benzene as shown in the following example. First is toluene methyl benzene, another is anisole methoxybenzene, another is aniline aminobenzene, and nitrobenzene and bromobenzene, and so on. If the benzene ring is disubstituted, the position of the substituent is defined by numbering the carbon atoms of the ring such that the substituent are located at the lowest number position or possible. 1-bromo or 1,2-dibromo benzene. 1-bromo group is occupied ortho position with respect to carbon 1. 1,3-dibromo benzene, there is 1-bromo group is occupied meta position with respect to carbon 1. And 1,4-dibromo benzene, 1-bromo group is occupied para position with respect to carbon 1. In the trivial system of nomenclature, the term ortho, meta, and para are used as prefix to indicate the relative position 1, 2, 1, 3, 1, 4 respectively. That's it for today. We can discuss the remaining portion the next classes. Okay, thank you.